This is our AP Statistics project for exploring categorical variables. So we'll start with frequency tables and bar charts. A frequency table is a table that displays the counts of outcomes in a sample. For example, this is a survey that takes the number of students with a certain number of pets. And as you can see, there are 2 students with 0 pets, 7 students with 1 pet, 3 students with 2 pets, and so on. So this is very good for displaying whatever data you collect in a sample. Another way to display this data is with a bar chart, which displays categorical data with rectangles proportional to the values they represent. They're very useful for side-by-side comparisons. As you can see here, this compares the San Francisco Zoo with the LA Zoo and specific animals, how many they are. For example, monkeys. You can see there are about 29 monkeys at the LA Zoo and about 23 to 24 monkeys at San Francisco Zoo. And that's very easy and a quick side-by-side comparison. A common mistake that people make with this is using pictures instead of bars, because pictures also have a 3D aspect and width, and the volume of the picture conveys a different message than just the height of a bar, so it can be very misleading. Another way to represent categorical data is using a stacked bar chart, which makes it very easy to see changes and trends and where they occur. It allows us to visually and easily compare distributions and see potential associations between variables. So as you can see here, this shows different sales strategies and how well they work on each product and how much it's sold. As you can see with sales strategy number 5, it sells a lot more product E than strategy number 3 does with product E. But strategy 5 sells a lot less product D than sales strategy number 3. So it's a very easy way to see comparisons between data and as well as trends.
Hi, so today I'm here to talk about marginal and joint frequencies for two-way tables. Two-way tables are used to organize data about 2 categorical variables. Here, the 2 categorical variables are gender and car owned. So the joint distributions and joint frequencies represent the numbers that are where 2 variables meet. So in the middle of the table typically. And marginal distributions are basically on the margins of the table and they only represent 1 variable. So for example here 84 represents the number of sports cars in total, but it doesn't represent anything about gender. And here it only represents the male and doesn't represent anything about any kind of cars. However, joint frequencies represent 2 variables at once. So 39 here represents the number of males that also own a sports car, so it represents 2 variables, joint variables. And then there's also frequencies versus relative frequencies. And 21 represents the number of male people that also own a sport utility vehicle. And basically 21 just represents the count. But sometimes we want to look at the relative frequency, which is out of everybody who's involved in this study or experiment, which is basically relative frequency, and that's 8.75%. So 21 is 8.75% of all people in the study. A tip while solving problems like this in the AP would be to circle, as you can see here, whatever you're kind of locating in order to eliminate other options, so you can focus on what you want to actually figure out. So for example here, if you look at option A, it says if a person owns a car, therefore a requirement for this kind of target audience would be in this top row, and that way you can compare the numbers in the top row and really easily rule out that that A is not true.
Today we're going to find out how to describe association between 2 variables by comparing appropriate conditional distributions. So an association is when knowing the value of one variable helps predict the value of the other. So let's take this example. Is there an association between gender and opinion about future wealth? If you look at the conditional probabilities, you can see that there's some difference between the almost certain response between males and females, and there's a difference in the good chance response between males and females, and some chance response between males and females. But there's almost no difference between a 50-50 chance and an almost no chance of future wealth. In this stacked bar chart, we can see that males are more likely to say that they have a good chance and an almost certain chance of achieving wealth when compared to women or females. So roughly, it seems like knowing that a person is male helps us predict that he is more likely to state that he has a good chance or almost certain chance of achieving personal wealth than a female. However, to be certain that there is or isn't an association between gender and opinion about future wealth, we need to see if these 2 events are independent. If a situation is independent, the 2 events A and B are independent if the probability of A given B equals probability of A, or the probability of B given A equals the probability of B. So in this case, if the probability of male, given that the person shows almost certain, is equal to the probability of male is true, then the event of being male does not change the likelihood of a person being certain about future wealth. So evaluating both probabilities, we see that there's a difference. So knowing that an individual is a male changes the likelihood that the person is likely going to say that they're almost certain of amassing wealth. So there is an association between the two variables, being male and the response almost certain of achieving wealth.